In this algebra video, we're going to practice and explain some concepts by standard. Now, the Florida standard we're going to be talking about is MA.912, meaning Math, grades 9 through 12. A stands for Algebra, and then Topic 2, Subsection 3. Basically, you can call it A.2.3. In other words, this standard tells us it is all about you need to be able to describe the concept of a function, use function notation, and determine whether a given relation is a function. Those are the things we're going to talk about. Now, you're going to get practice problems in this video. I think I have roughly 9-10 practice questions in this, and they're coming straight from the practice EOC questions for the end of course exam we're doing in our class. The questions we're going to talk about are here. We're going to talk about these question numbers, and I kind of wrote a quick basically detail about each of them so you know what they're about at a quick glance. And I will add timestamps to these in the details. If you look at the details of this video, I'll add timestamps so you can skip ahead if you only need certain questions. No big deal there. Let's get some perspective for a minute. A lot of questions are going to ask you, is it a function? They're going to give you a table, they're going to give you a graph, they're going to give you a little input-output visual, and they just want to know, is it a function, period. Basically, all things are relations. Somehow they're relating an input to an output or an x to a y, whatever. But the rules you need to keep in mind is every input can only have one output. Visually, that means that the graph must pass the vertical line test. So to give you some examples, if I were just to draw any line, draw a line like that. Imagine a vertical line. Okay, notice that red line only crosses it once. No matter where I could draw that red line, even if I drew it over here, it still would only pass only once. So because this vertical line, no matter where I put it, passes this graph only once, that means every input only has one output. Now let me show you what happens when it is not a function. So this first example is yes, a function. So I'm going to say yes, a function. Now imagine this graph. If it did that, you can't really see, I hit the axis. If it did that, if you were to draw a vertical line, notice it hits twice. Because it hits twice, it fails the vertical line test. So this is not a function. Not a function. That's what I mean by visually. Meaning, if you had a table of values, let's say that was x equals 2. Let's say that was 1, 2, 3. In your table of values, your x, comma, y, that's a y, you would have an input of x. The input of 2 would happen twice. One of them would be 1, one of them would be 3. They're basically saying this one input of 2 is giving you two different outputs, and that goes directly against what I just told you. Every input can have only one output. So in a table, it'll look like this. That means not a function. If visually in a graph, it'll look like where if you could imagine a vertical line, if it hits it more than once, not a function. And honestly, I had a third example that it's not really going to be necessary. I kind of covered it visually. That's all you need to know about whether it is a function, yes or no. So I may have already given away the answer to this question, but basically let's talk about number 2 first. Which of the following tables does not represent a functional relationship? Now remember what I said. I said every input can only have one output. So basically the fast way to do this is look for any repeats of inputs. So I see 1, -1, 2, -2. No repeats. So that means it doesn't mention anything about 1 giving us something else. No repeats in this one either. No repeats in this one either. Oh look, we have repeats in this one. Okay, so let's check this one. This one looks suspicious. The input of 1 gives you a 9. The input of 1 also gives you a -9. Oh, so the one input of 1 has two outputs of -9? Yeah, that's a problem. That's not going to be a function. And look, the same thing happens with the input of 2. You get +5 and -5. So because of that, that one input gives you two outputs for each one. That is not going to be a function. So we actually found our answer. Now, mind you, if these other examples had -1 twice, but if they listed -9 twice, I highly doubt they'll do that to you. That's more of a typo. That would not count as of an input having two outputs, because technically it's the same number listed twice, the same output listed twice. I don't think that's going to happen, but just keep an eye out, just in case. All right, so we found the answer. Option B is not a functional relationship. So now let's talk about function notation, but let's first talk some perspective. Perspective, function notation. Let's make this clear, guys. Now, when you see the phrase f parentheses x, that's pronounced f of x, or it's pronounced function of x. And in other words, it is a function, it is a process that depends on x, meaning whatever's right here is your input. This does not have to be an f. You will see it as like a g, an h, whatever. So it just stands for f function, or if it's g, you'd call it function g. Like if there was a g here, you would just call it function g. But this means the function of f. When you see that though, it means the same thing as y. It's an output, meaning they both depend on x, like normal, input, output, independent, dependent variable. It's just your output, that's it. So now, this is the actual notation I want you to focus on, other than knowing that, don't think that means, that does not mean f times x. This does not mean f times 2. This means, notice there used to be an x here, this means you plug 2 in for x. So let's do an example. And I just changed the letter just to be arbitrary to show you the letter can be different. G of x equals 3x squared plus 4x plus 1. Well, if you're told to evaluate, or you're just given this, usually use the word evaluate, that means this tells you what to plug in. Notice, all those x's are now what they told you to plug in, 3. So it just means plug in for it, and now you just use the order of operations to evaluate. And then when you had your answer, which is 40 by the way, you would see function notation like this. G of 3 equals 40. That means, that tells you your input of 3 gave you an output of 40, meaning you had if you were to graph it, you'd have an ordered pair 3, 40. That's what function notation means. You will see questions like this that tell you to evaluate, and they'll use this format. Don't freak out when you see f of x. It does not mean any actual mathematical operations. It just means plug that in for x, or it means output. So let's take a look at this question. Paolo was given the equation y equals negative x plus 3. Which of the following is an equivalent representation of this equation? Look at each of your options. Notice, all that's really changed is they've started using f of x, f of y, f of y. But before you just go winging it, there is a rhyme to it. I know you're already going to assume it's f of x, and you are correct on that. It is a. But let's make sure we're clear why for a moment. This function we have, this will just take a moment. Notice it's x. Then you're doing crap to it. You're multiplying it by -1, then you're adding 3. X is the input. Everything depends on x. That means whatever function notation you have, x needs to be in the parenthesis. So it's only down to a and c. B and d are out because they have y in the parenthesis. The way this is written, it does not depend on y, it depends on x. And then you work your way through. I've already told you f of x is like saying the output. So all you do is replace y with f of x. And so that's all they did. And so the answer is A. No work to show for this one. While we're on the top of the function notation, let's jump ahead to question number 62. Let's go evaluate a question with function notation. So take a look at 62. And if you think you already can handle this one, hit pause. Try it yourself first. Okay, so when they tell you f of 2, they're telling you to plug in 2 into x's spot. So go ahead and get it set up, and I suggest you use parentheses to be cautious. And now put a 2 into its spot. Now follow the order of operations. 2 squared is 4. Notice, it is not negative 2 squared. That's why I mentioned using parentheses. Because technically in the question, there's a -1 in front of that x. There's a -1 in front of that x. So when you plug in, you do what it says to do, then you can multiply by that -1. Okay, so 2 squared is 4. So up top, we have 3 minus 4. Or think of it as positive 4 times that -1 in front. Well, that's -4. Same thing as -4. So those two ways of explaining it agree with each other. Now, on the bottom, we just have 3 minus 2. Well, 3 minus 2 is 1. Well, up top, 3 minus 4 is -1 over 1. -1 divided by 1 is just -1. So our answer is going to be B. So that's it. That's the function notation. Now you could go further, and sometimes the answer choice may be written like this, where they're expecting you to realize that the input of 2 gave you an output of -1. So this is the function notation way of writing the answer. Now we're going to do one more question that's kind of mostly focusing on function notation. Let's talk about working backwards with function notation. I'll show you what I mean in just a moment. Let's go to number 47 next. Alright, take a look at number 47. Number 47 tells us the total cost f of d, meaning the function that depends on d, in dollars. So it clearly depends on d, dollars. That's what d is going to stand for. Oh, excuse me, I apologize. D for days, apparently. Anyways, the total cost in dollars of renting a sailboat for D number of days is given by the function. And then they give it to you, meaning D is the input, the days is the number of input. If the total cost was $360, for how many days D was the sailboat rented? Okay, so in other words, they told you f of D is the total cost. F of D is the output. And then they go on to tell you the total cost is $360, meaning they just told you the output was $360. So literally, you write this question, and this is what I mean by working backwards, and 120 plus 60D. And now your job is to work backwards and solve for D. Usually we plug in for D and get Y, but in this case they gave you the output, so they want you to work backwards to solve the input. Now I know you can handle this two-step linear equation, but go ahead and knock this thing out. Alright, so it comes up with D equals 4, and that stood for days, so 4 days. So that tells us it would take 4 days for the total cost to be $360. Now, and that actually kind of makes sense, because if you look at your function, think of this as like y equals mx plus b. Well, this would be b, and this would be m and x. So that tells you the slope is 60, meaning the rate of change. And so that must represent, if it's being multiplied by the number of days, that must represent the cost per day. And 120 must be like a flat rate, one-time cost, whether it be a cleaning fee or whatever. Maybe it's an insurance fee. So this equation kind of follows how the situation would work. Alright, that's number 47. Alright, so now we're going to talk about how to fit a function to a problem, how to fit an equation to a word problem. I keep using the word function. It sounds fancy. Really, I'm talking equation, guys. I'm just talking some kind of expression, but a function is usually an input-output situation. So let's do 12 and 61 is what we're going to do next. Let's start with 12. Alright, so number 12, let's use some test-taking strategies. Let's start with reading. Sometimes the last sentence first can help, and it starts with which equation. It says, which equation could you use to calculate the distance D from the top of Brock's head to the ground if R represents the number of ladder rungs he has climbed? And in other words, when he climbs up the ladder, the height of his head is going to be how high is he standing, and then plus how tall he is. So when he's still on the ground, when he's walked 0 rungs or 0 steps in the ladder, his head is still 6 feet from the ground. And you know that because Brock is 6 feet tall in the beginning of the question. So even at 0 steps, he's still 6 feet tall. So you want to kind of look to see which equation is going to tell you he's still going to have a height of 6 even with 0 rungs. And so you can look for different ones. For example, option C would still give it a value of 6 at 0 rungs. Option A would give it a height of 6 at 0 rungs. And the other two, they would not. Now, that's one way to do it. That's test-taking strategy. But now there's another way just to interpret this question yourself. Here's a great rule of thumb that works in most cases. Think of it this way. Look for numbers, and then look for values, and then ask yourself, does that value happen more than once? Let's start with what I underlined in red. Each rung of the ladder is worth 1.2 feet higher. So ask yourself, does that happen more than once? And I think you can already tell, yes, there's more than one step on a ladder, of course. That happens more than once. So because that happens more than once, this 1.2, this value of 1.2, is going to be multiplied by something because it happens more than once. Okay, so let's look for another value. And you look for other numbers, trying to talk about what's something else going on. But you'll notice it doesn't quite mention it, but it was in the very beginning. Him being 6 feet tall, that height, he's only ever going to be 6 feet tall. He's never going to get 12 feet tall, 18 feet tall. That's not going to happen. So that's a constant. So his height of 6 feet tall only happens once. Therefore, it will not be multiplied by anything. So that can help to kind of help you see which equation is which. Because anytime you have some kind of a rate, or like usually use the word per, like for example, this could have said 1.2 feet per step or per rung. The words like per or for every, that indicates a rate. And your rate's going to be multiplied by something. So now I'm over explaining it, but my point is I was just trying to help you to pick any type of question. This is a good way to pick apart certain parts to know who's being multiplied by something, who's not. Alright, so I think you've already figured out at this point. It's going to be option A. If you haven't done so already, let's make sure we're clear why. His distance from the ground, okay, is going to be how many steps times 1.2 plus his original 6 feet. That's how we're going to calculate the height of his head from the ground. And that's matching a function or an equation to a word problem, interpreting it. This is a valid problem-solving skill because it can help you set up many more complex questions. We're now going to talk about number 61, another question where we're going to fit a function to a problem or write an equation and match a problem. Okay, we're at a local grocery store. Watermelons are sold for $4 each plus an additional 25 cents per pound. Now, use what I just said in the last question, but let's go ahead and finish reading just to be sure. Write a function that describes the relationship between x, which stands for the number of pounds of watermelon, and f of x, the total cost of the watermelon. Well, I think you'll notice the total cost depends on the number of pounds. That's where I mentioned the function notation in the beginning of this video, where I talked about f of x is a fancy way of saying output, or y, but it's saying the function that depends on whatever that letter is, x. In this case, we're calling it function f. It could be a g and h, like I've already mentioned. Alright, so think of this as just an input-output situation. That's all it is. So you can think of it as y equals, if that's what you're comfortable like we're used to doing. Now, let's go through and look for things that happen once or more than once. For example, watermelons are $4 each plus an additional 25 cents per pound. So that 25 cents per pound, that happens more than once. That is your rate. That is your, in this case, it's going to be a slope, but we didn't quite know that until we knew this was going to be slope-intercept form, which you may not still know, but here's how we do know. 25 cents per pound, we just said, happens more than once. So that is what's being multiplied by the number of pounds. Now, this $4 is only happening once, and it's clearly going to be added to your cost, especially because it says plus, but just using your common sense. So we're going to add 4. Now, it turns out this was slope-intercept form, where our output of y, or f of x, depends on our input. So we've got our answer now. The worst thing they're going to do to you is they're going to try to change the order or write it in the equivalent form. In this case, they chose the answer choice that put in the order that the question was in. But this was actually slope-intercept form in disguise. So number 61 is B. While we're on the topic of matching or writing functions or equations to match questions, let's go ahead and do number 17. Let's talk about matching a function to a table. So let's do number 17. Alright, number 17 says, which of the following equations describes the same function in the table below? Now, there are many ways to answer this question. There's a few. Some of you might have a fast way, some of you might have a slow way, some of you might have an intuitive way, some of you might have a guess and check way. Well, the good news is, even the guess and check way would work, but there's some ways to be efficient. That way you don't guess and check more than you need. So let's take a moment to review a basic skill we already know about situations, especially taking a glance. All these answer choices, all these are lines, and in fact we know they're all lines because they're in slope-intercept form. So we basically can say, okay, what are the key characteristics of slope-intercept form? Let's do a brief, quick rundown of reminding ourselves what that is. You've got M. M stands for your slope, and then you've got B, and B stands for your y-intercept or your constant. M is your rate, B is your constant. Okay, so those are some key differentiating characteristics of these equations. Notice the y-intercept is either -2 or +2. That's what they've narrowed it down to for us. The slope is either 5 or 1 over 5. That's what they narrowed it down for us. So let's start by finding one of those. And the easiest one for us to find in the beginning is the slope. So let's find the slope first. As a brief reminder, slope is rise over run, or change in y over change in x, or change in output over change in input, or change in dependent variable or change in independent variable. It has all kinds of names. They all mean the same thing. So I want you to find the change. Going from here. And it may not be constant in case they jump a bigger jump besides 3 to 4, but just let's look at the change. In this case, it was constant. Each time it goes up by 5. And then again, if it doesn't do it every time, it's not necessarily a bad sign, but if this is constant, like goes up by 1 every single time in this case, and then all of a sudden this jumped, it wasn't by 5, then we might not be dealing with a line. But in this case, because this goes up by 1 each time, this goes up by 5 each time, it's constant. We don't have to worry about anything. Okay, so we're going up by 1 over here, we already said, each time. Alright, so our change in y is going up 5. Our change in x is going up 1. So if we go to write that equation, we have 5 over 1. So our slope is 5. So we know our slope is 5. I could write better 5s than that. So we know our slope is 5, m. That tells us we've narrowed it down to A or C. It's definitely not B or D. So B or D are out because they have the wrong slope completely. Our job now is find the y-intercept. We know we need the y-intercept because that's the other part of slope-intercept form. That's how it gets its name, slope-intercept form. So let's find b. Let's find the y-intercept. I got good news and good news. Good news is, back when we were doing this in class, you guys were really good at this. You were able to find slope-intercept form really solid. That's the good news. Well, I guess there's slightly bad news. Bad news is, I've been sensing some of us are a little rusty on this. We need to review. The good news is, though, there's two ways we can find it. One way we already learned. It maybe takes an extra moment or so. And the other way is a way that you may not quite know, but may feel good. It may feel right to you. So I'm going to show you both ways that you could find the y-intercept in this question. That's what I'm going to do. And they're both going to revolve around linear equations forms that we know. We're going to talk about slope-intercept form, and we're going to take a moment to talk about point-slope form. Alright, so point-slope form. It gets its name because its name is what you need. You need a point, and you need a slope. And you put in the x-coordinate of your point right here. You put in the y-coordinate right here. You put in your slope right there. I taught you guys the point-slope form method because it was a way that always works for all linear equations. This version can easily be turned into slope-intercept form. This version can easily be turned into standard form. It has its uses. So for that reason, this was the way I showed you how to do all these questions. It always works. So this is the way I'm going to show you first. It's the way it's going to hopefully looks the most familiar. But it's also a good review of point-slope form. Alright, so what you do is we already know our slope. Our slope is 5, so that's taken care of for us. We know that our slope is 5. We now have to pick a point, and we could pick any point. Point-slope form works with any point. Now, so to keep my math easy, I'm just going to pick the smallest point, 2, 8. That's what I'm going to pick. So the point I'm going to use is 2, 8. Alright, so let's set this up and plug in for those values. Alright, I just wrote it again and left blanks. So our y-coordinate is 8. And notice the formula is y minus y1. So if this had been, let's say, what if a negative 8, when you minus a negative, it becomes adding. So we would have said plus 8 if it had been negative. But since it's positive, we just say minus. Alright, now our slope is 5, and our x-coordinate is 2. Oh, I left that negative sign on the 8. Let's get that off there. 5 and 2. Okay, so now your job is put it in slope-intercept form, meaning get y by itself. Meaning, let's ditch this parenthesis first with the distributive property. So we can start to get y by itself. Well, that's 5x minus 10. Remember, common mistake. Make sure you do multiply the second one. Drop everything down and finish getting y by itself. We finish getting y by itself by adding 8 to both sides. Let's get that 8 out of there. And when we do that, we're left with y equals 5x, well, negative 10 plus 8, that is negative 2. So we have 5x minus 2. So that's the equation of our line. So like we already said, the thing over here that is being added, that is your y-intercept. So that means our y-intercept is negative 2. That is the y-intercept for this question, negative 2. So if they were asking just for the y-intercept, you found it. But in this case, they were asking for the whole equation. So our equation is y equals 5x minus 2. Now, stick with me for a moment if you want to see a slightly faster way that I think would be a good idea to add to your arsenal to help you answer this question. I showed you the way using the skills we have in the past, but I want to consider this method, okay? Give it a chance. Alright, so here's a different way of thinking of the same question. This way works as you basically fill in for y, you fill in for m, and you fill in for x, and you solve for b. Well, we know m, and some of you might think, well, what's y and x? Well, it's what we just did. You pick one of these combinations. It doesn't matter which one. So what you're going to see me do is you're going to see me pick a combination. I'm going to pick 2 and 8. So I'm going to change y to 8. I'm going to change x to 2. And I'm going to change m to 5. That's what you're going to see me do. That's what I'm going to do right now. So notice, I wrote y equals mx plus b, but I filled in for y, filled in for x, filled in for m. We're going to solve for b. Okay, so 5 times 2 is 10, so we have 10 plus b equals 8. Now, we have to get b by itself. We want to solve for b. So let's subtract 10 from both sides. And when we do that, we have on the left side, negative 2 equals b. Okay, so this is important. We now know our y-intercept. We just found out b is negative 2. Well, we already knew our slope. Our slope is 5. I'll circle it over here. So that's the information you need to write the equation in slope-intercept form. You know that your slope goes in front of x. You know your b goes out here. So we now know our equation, y equals 5x minus 2. Notice, same answer. And some of you might think that this took less steps. Some students don't like this method because it's not just plug in and then it's simplified your answer. You basically got to plug in right here, and then solve for what you don't know, and then take what you just found out plus what you already knew, put it all together to slope-intercept form. So this tends to, people don't always like this method, but it does work, and I think you'll notice it actually, I feel like it took less writing. And this is a good way to do slope-intercept form, but this method only works when looking for slope-intercept form primarily. All right, so I'm proud of you if you took the time to look at this method of finding it. Consider it. Some of you intuitively try this method without realizing it's a legitimate thing, and you think you're doing something sneaky you're not quite allowed to do. But the truth is, you are. All right, we got 2 questions left. We've got predicting with a function and matching a function with a graph. Now, let's go ahead and since we're talking about functions and matching them and writing them and using them, let's go ahead and do the predicting one next. We're going to do number 11. All right, number 11. Let's see, it tells us, I'm going to go ahead and read the last question first. It tends to give you good perspective, good test-taking strategy. It says, if this trend continues, in which week will she give a 12-minute speech? Okay, 12-minute speech. That's something to keep track of. But notice, when I say read this last sentence first, that's not code for ignore the entire question. That's just what I mean by giving yourself perspective, what it's about. Meaning, how many weeks will it take for her to go by before she can do a 12-minute speech? So let's read the question. Alyssa is enrolled in a public speaking class. Each week, she is required to give a speech of greater length than the speech she gave the week before. The table below shows the lengths of several of her speeches. And then they go ahead and tell us, as the weeks go by, 3, 4, 5, 6, notice her length of her speech is going up. It goes up by 30 seconds, goes up by 30 more seconds, then 30 more seconds. So that's what they mean when they say, if this trend. That trend is increasing 30 seconds every week. That's what they're saying. So basically, we want to find out, all right, if this trend continues at 30 seconds every week, at what point will she be at 12 minutes? Well, some of you might be thinking, this is minutes, and this is in seconds. So let's do a quick conversion. 12 minutes times 60 seconds in a minute, well, that's 720 seconds. So we're looking to see, when will her speech be 720 seconds? That's what we're doing. Some of you might be tempted to use a proportion to solve this because you're like, oh, 3 over 150 equals blank over 720. And the truth is you can't use a proportion because that's implying that this is a directly proportional question. We know it's not directly proportional because if you worked backwards, week 2, week 1, week 0, you'll notice you won't end up at 0. So at week 2, she's at 120. At week 1, she's at 90 seconds. At week 0, she's at 60 seconds. So you'll notice it doesn't start at 0, 0. It doesn't come from the origin. That's a quick check way of knowing it's not directly proportional. You cannot use a proportion for this one. But I bet you that answer choice, one of these is probably available if you were to use a proportion. I can think of at least 2 ways for you to solve this. Off the top of my head, I think you may like the first one first. The first one is a lot of us like to look for patterns because that's a good thing. Patterns, that's how that's inductive reasoning. You're looking for what do you see, what do you know, what can you figure out from it. And some of you might be thinking, okay, we're at 240 seconds. We need to get to 720. Some of you may already be subtracting knowing how much more you need. So you might be thinking, okay, we know she needs 480 more seconds. Well, you know every week that goes by, she gains 30 seconds, okay? So that means we can take that increase of 480 that she needs and divide it by 30. This might be how some of you are thinking of this logically. And do 480 divided by 30. Okay, and if you do that, you get 16, meaning 16 weeks need to go by. The answer is not 16, though. The answer is 16 weeks after week 6. Well, 16 weeks after week 6, meaning add 6, that tells you 22 weeks. So that's actually going to be your answer. Some of you may have liked that method. Some of you might be like, well, what just happened? That doesn't quite make sense. Or some might be thinking, well, I know this is a linear constant change situation. I'd rather use the equation that I feel safe doing when I can prove it. Well, if you're one of those people, I'm going to welcome you to consider this is the reason why I left this up here. Coincidentally, not coincidentally, but because I went back to x equals 0, that's our y-intercept. Our y-intercept is 0, 60. This graph, this line, will cross the y-axis at 0, 60, meaning 0 weeks, 60 seconds. So if we were to go write our slope-intercept form of this equation, of this situation, y equals mx plus b, our constant, meaning our b value, is going to be 60. So we're going to have plus 60 at the end. And remember, M is just your slope. Well, our slope was going up, it's our rate, going up by 30 every week. So 30 seconds per week. So that's our equation. So you actually could find the equation of this. You could have done it more complicated. You could have taken 2 points, found the slope, then used point slope form, meaning the stuff we talked about in the question I did just before this one. You could have done all that, but there was actually a shortcut to finding the y-intercept in this question. So once you have your equation, you say, you know she needs 720 seconds. So if she needs 720 seconds, that's y. And so you just write down the rest. So in this case, you're working backwards. You actually know y, and you're solving backwards to find x. So subtract 60 from both sides. You get 660 equals 30x. Now divide both sides by 30 to finish getting x by itself, and you will have your answer. And you get x equals 22. So a lot of people like this way because it allows them to solve straight to their answer. 22 meaning 22 weeks. So these two methods agree. They're the same thing. I don't care which one you use. I just like to sometimes present alternate ways of doing it if it doesn't take too much time. So consider both of them. Alright, so down to our last question. Let's match a function with a graph. And I already looked ahead. It turns out that it's the quadratic function. So this will be a good question because I'm gonna look at it as like a regular, what kind of things can you use for any function, but then I'm also going to talk about some specific skills specific to quadratic functions and quadratic graphing. I've already kind of mentioned some linear stuff during the rest of these other questions. Alright, so to make it easier to read on the screen, I went ahead and rewrote the equation nice and big at the top. But basically the question said, which of the following is the graph of the function, and then wowza, y equals x squared plus 2x minus 3. So I wanted, before I even consider the fact this is a quadratic, we just learned something recently about quadratics in chapter 8, chapter 9. But specifically, let's just talk in general about functions for a moment. I want to give you some perspective. The way to do the graph of any function, it's not always the fastest way, but it's a way that always works that I know you can trust, you just don't always think about doing it. Here it is. Make an input-output table. Yes, I'm talking about that old school, feels like archaic way of doing it, where you just make up numbers for x, -2, -1, 0, 1, 2. Those are popular ones to choose. Just make up numbers. And then plug those in for x, meaning your inputs. And then see what you get for your output and putting in here. That's old school. Do the input-output table. But here's the truth. That works for anything. So even if on the EOC or anytime you feel like they're giving you an equation you don't recognize, maybe you feel like you don't remember what the shape of that equation is, whether they try to give you like a square root, that is a square root, or they try to give you absolute value, or they try to give you x cubed. It doesn't matter. If they give you one you don't feel like you've seen, you can find all of them by doing a simple input-output table. Yeah, it'll take you a moment to set it up, but once you do, it gives you some definite points that you can graph to visualize what direction does this line go. So I want you to consider that as a valid method for all function graphing questions. Of course, it's not the fastest, but it's a way that always works. However, for this question, I'm going to use what we learned recently about graphing quadratics to help speed us up a little bit. And when we learned how to graph quadratics, the way we did it is we learned to first find the vertex, or at least find the axis of symmetry. So if we're going to find the axis of symmetry, we need to use that formula. Okay, so over here on the right, I've written down the formula. It's opposite of b over 2a, and this will give you the x-coordinate of the vertex, or the axis of symmetry, because the x-coordinate of your vertex, so if your vertex is at 2, 3, this x-coordinate, x equals 2, that's your axis of symmetry, as a made-up example. Alright, so quick reminder, if we're going to use this formula, or if we're going to talk about quadratics, let's make sure we know the standard form of quadratics. The standard form of quadratics is y equals, or 0 equals, ax squared plus bx plus c. Now sometimes there's a y here, there's a 0 here. It's still the same standard form. So that tells us, if we're looking for a is the number in front of x. Well, in this case, the number in front of x is an assumed 1, the coefficient of 1. B is the number in front of x to the first power. So that tells us that's b. So let's fill these into their locations. So we know that this formula is opposite of b all over 2 times a. Okay, so let's get that ready. So opposite of b is 2. Well, the opposite of 2 is -2. Notice I'm saying opposite because that's more specific than just saying negative b. Because if this was already negative, some people think, oh, it's already negative, so it's already negative. But if that was already negative, we would have plugged in a negative, and then a negative -2 would have been a +2. So that does change things. So it is correct, more proper to say opposite of b. All right, well, 2 times a. A is 1. 2 times 1 is 2. Negative 2 over 2, well, that's just negative 1. So that tells you the center of your graph, meaning your vertex, your axis of symmetry for quadratics. Because notice, quadratics, what they all have in common is they all are symmetrical. Oh, I missed. They all are symmetrical down the middle, okay? So what we just found was the value of the middle. And we just found out that it is at negative 1. So at a first glance, look to see which one of these graphs has its vertex at x equals negative 1. You'll notice this one is at x equals positive 1. And so is this one. So you already know it is not going to be A or C because they have the wrong axis of symmetry. A and C are out. You also can use another shortcut that we already learned. Look at the difference. These two parabolas, one opens outwards, one opens downwards. So test-taking strategy, you notice that your leading coefficient is positive, so you already know this parabola opens upwards. If that had been a negative one right there, the parabola would have opened downwards like that. So we've actually already narrowed it down and already know our answer, test-taking strategy, to go ahead and know this parabola is going to be opening upwards, so it must be option D. We know it's not A or C, it must be D. Now, for a quick check, not really sure if you have the right answers, confirm that you at least have the right x-intercepts. Oh, but those were the same between these two. So finding the x-intercepts would not between D and B. That would not have been a differentiator to help you tell the difference. It helps you to use what we just knowing to open upwards. But if you still aren't sure, you still don't trust it, plug in a few points. Plug in a few points into an input-output table to really decide. For example, you know your vertex is at negative 1. So if you plug in a negative 1, you'll have negative 1 squared plus 2 times negative 1 minus 3. Okay, well, negative 1 squared is positive 1. 2 times negative 1 is negative 2. Okay, so we have positive 1 minus 2. Well, that's negative 1. All right, so we have negative 1 minus 3. Negative 1 minus 3 is negative 4. So that tells us we have a point at negative 1 comma negative 4. And you'll notice that's where this location is right there. I missed. This one is at 1 comma positive 4. That's why option B is out. It cannot be B because that vertex is in the wrong spot altogether. So I think I've convinced you. If you have enough information to know, it is option D. That is the graph of this function. Consider the old-fashioned input-output table to help narrow it down, but feel free to use what you know about the standard form of these graphs. If this was a linear equation, I would have checked the slope and the y-intercept, and that would have been enough to tell which one was which. And notice, just by knowing that this graph opened upwards, if you at least knew that, because it had a positive leading coefficient, you already knew it wasn't A or B. So you could have already cut this out just knowing it was a positive leading coefficient. Use your small bits of skills. Alright guys, so that's going to be the last question in this first set of questions that I'll go with the standard MA.912.A.2.3. This was all about functions and the concept of what a function is, the function notation, and whether it is a function. Okay, stay tuned for the next video if you need more help. Take care.